Imagine flying from London to Sydney in under 2 hours. No pilot, no traditional jet engine, no returning home, just a machine built to break physics. In 2004, NASA built the fastest air-breathing aircraft ever flown. It was called the X-43A, and it changed aviation forever. For decades, engineers dreamed of hypersonic travel. Hypersonic means faster than Mach 5. That's 5 times the speed of sound. But here's the challenge. At those speeds, air becomes violent. Friction turns into extreme heat. Engines fail. Materials melt. Traditional jet engines stop working around Mach 3. Rockets can go faster, but rockets carry their own oxygen. They are inefficient for atmospheric flight. NASA wanted something different. An engine that could breathe air and still fly at hypersonic speed. That engine was called a Scramjet. And proving it worked was the mission of the X-43A. The X-43A was part of NASA's HyperX program. It looked small, only 3.7 meters long, but inside it carried one of the most radical engines ever built. Scramjet stands for supersonic combustion ramjet. Here's what makes it insane. Normal jet engines slow incoming air before combustion. A scramjet does not. Air enters at supersonic speed. Fuel is injected. Combustion happens while airflow remains supersonic. That is like lighting a flame inside a tornado. No turbines. No spinning compressors. Almost no moving parts. Just pure aerodynamic compression. If this worked, it would unlock a new era of flight. But there was a problem. A scramjet cannot operate at low speeds. It needs extreme velocity just to turn on. So NASA had to get creative. Step 1. A massive B-52 bomber carried the X-43A under its wing. Yes, the same bomber used during the Cold War. Step 2. Attached beneath the X-43A was a Pegasus rocket booster. At about 40,000 feet above the Pacific Ocean, the rocket was dropped. It ignited and accelerated toward Mach 10. At nearly 95,000 feet, the X-43A separated. Now it was on its own. On November 16, 2004, the Scramjet engine ignited. For about 10 seconds. Just 10 seconds. But those seconds changed history. The X-43A reached Mach 9.6. That is nearly 11,000 kilometers per hour. It became the fastest air-breathing aircraft ever flown. Not a rocket. Not a missile. An aircraft using oxygen from the atmosphere. After its powered flight, it glided down into the Pacific Ocean. Mission complete. The vehicle was never recovered. It was built only to prove a point. And it did. At Mach 9.6, the air temperature around the vehicle rises dramatically. Compression heating can exceed 1000 degrees Celsius. That's hot enough to weaken metal. At hypersonic speeds, shockwaves form. Air chemistry changes. Control becomes extremely unstable. And remember, the X-43A was fully autonomous. No pilot. No remote joystick. It was guided by onboard computers making split-second corrections. 10 seconds of stable hypersonic combustion was considered a massive success. The X-43A proved Scramjet's work. That single experiment influenced hypersonic research programs, advanced defense systems, future reusable spaceplanes, faster global travel concepts. Imagine aircraft that take off from a runway, accelerate to Mach 7, and then transition into space. Reusable, faster, cheaper than traditional rockets. The X-43A was a stepping stone. A small vehicle with enormous consequences. The entire powered flight lasted less than 10 seconds. It flew nearly 10 times the speed of sound. It remains one of the fastest air-breathing vehicles ever tested. Sometimes, progress is not measured in hours. It's measured in seconds.